James Webb Space Telescope, also referred to as JWST, is currently the largest and most powerful optical telescope in space. It is a space telescope that is invented to deal with infrared astronomy. Infrared astronomy is the part of astronomy that centers around the observation and analysis of astronomical objects through infrared radiation. This means the James Webb Space Telescope is used for looking at all sizes of objects in space with an improved infrared resolution. The James Webb Space Telescope was invented by an international collaboration involving three nations, that is, National Aeronautics and Space Administration, the European Space Agency, and the Canadian Space Agency. The optical space telescope was designed and developed by Northrop Grumman, an American multinational aerospace and defense technology company. It was launched on the 25th of December 2021 on board an Ariane 5 rocket, a heavy-lift launcher considered one of the world's most reliable launch rockets. After over 25 years of being in development and a budget of around $10 billion, John Webb has only proved to be the telescope we have all been waiting for. It can detect infrared cosmic light with wavelengths that are far longer than human eyes can see. James Webb is great at penetrating dust clouds and illuminating hidden areas where the stars and solar systems are being formed. It can also correspond with the emissions of extraordinary objects and planets. JWST's new discoveries. Another important point is that the large optical telescope will assist astronomers in getting data from the solar system. With the retrieved data, researchers will be able to know more about other planets and make comparisons between them. Most unanswered questions over the years will be answered, and analysis will be made. We might get to know what planets are habitable and which ones are not. The most impressive aspect is that James Webb can study the universe with infrared wavelengths, which will help find possible planets like Earth. According to a statement made by Joanna Bastro, an astronomer who conducted a study, she said, "Different gases have already been identified successfully in the atmospheres of several large, hot, Jupiter-sized planets by studying variations in the starlight that passes through their atmospheres when they cross in front of their parent stars. Studying planets the size of Earth is an even greater challenge. Although JWST would struggle with analyzing a solar system exactly like our own, it would be capable of studying Earth-like planets around cooler stars if such a system were to be found." JWST can detect infrared wavelengths for fingerprinting, chemicals like water and methane in the atmosphere of exoplanets that are beyond our solar system. Study of black holes. James Webb Space Telescope has a near-infrared spectrograph instrument capable of identifying black holes in their active phase, a period in which black holes grow by consuming lots of surrounding matter. Usually, black holes are known to be invisible and light cannot escape them, but surrounding matter like dust and stars can be seen around the black holes. Researchers were known to use X-ray telescopes in studying them, but Webb will allow researchers to see all that happens at the corner of the black holes through its infrared instrument. It can also see through the temperatures, speed, and chemical components of the black holes. The light emitted by surrounding matter and the velocity of gas orbiting the black holes can also be observed by JWST. Detection of stars in old galaxies. Stars are said to be birthed in places full of dust. The dust prevents scientists from seeing right into the clouds using visible lights, but infrared light can penetrate through the dust. JWST has a broader infrared range that will allow scientists to see deeper into the dust and make out newly emerging stars. Also, the capabilities of the James Webb Space Telescope allow scientists to observe galaxies. In the past, scientists used telescopes to observe a galaxy back in time. With JWST, they could study the galaxy's different stages of growth and development. Daniel Epstein, an astrophysicist, says, "It is the first time we had a large cold telescope in space that can observe these infrared wavelengths." He says with Webb, they can use its cameras to travel back to when galaxies formed after the Big Bang. The first images from the James Webb Space Telescope were broadcasted on the 12th of July, 2022. It is the first set of full-color scientific images and spectra gathered by the observatory. It is a view of the galaxy cluster in the southern sky called SMACS 0723, which is about 5 billion light-years away. As NASA stated, this image is approximately the size of a grain of sand held at an arm's length. Because of its immense size, the cluster magnifies and distorts background galaxies through gravitational lensing. Some of these lensed galaxies are the youngest galaxies in the field, being seen at a time more than 13 billion years ago, a billion years after the Big Bang. Earlier, Webb researchers had extracted the spectra of one of the earliest galaxies, showing traces of hydrogen, oxygen, and neon atoms. The three-dimensional pictures revealed the previously invisible areas of star birth. In the picture was a landscape of mountains and valleys, speckled with glittering stars near the edge of a nearby young star-forming region called NGC 3324 in the Carnea Nebula, which is located in the Milky Way about 7,600 light-years from Earth. The mountains are studded with glittering young stars imaged in infrared. The nebula is believed to contain a seemingly endless supply of gas and dust from which new stars and planets are born. According to Amber Strawn, the deputy project scientist of JWST, today for the first time we're seeing new stars that were previously completely hidden from our view. A hollow region appears carved from the nebula. This is due to the intense ultraviolet radiation and stellar winds from extremely massive, hot, young stars in the center of the bubble above the area shown in this image. The steam that appears to rise from the mountains is hot, ionized gas and hot dust streaming away from the nebula because of the relentless radiation. Protostellar jets shoot from some of these young stars. The youngest sources appear as red dots in the dark, dusty region of the cloud. Young stars and their dusty planet-forming disks shine brightly in the mid-infrared, appearing pink and red. The JWST has revealed new details of the Southern Ring Nebula, a planetary nebula cataloged as NGC 3132 that is 2,500 light-years away. This is a complex system where two stars are locked in a tight orbit. Observing the nebula in mid-infrared wavelengths has shown the second star at its center in far greater detail. Planetary nebulae have existed for thousands of years. During this period, the dimmer star at the center of this scene was known to send out gas and dust rings. In the image on the left, the stars and their light layers are prominent. The image on the right shows for the first time that the second star is surrounded by dust. The brighter star is in an earlier stage of its stellar evolution, and as the stars continue to orbit one another, they stir the pot of gas and dust, creating cosmic imagery of asymmetrical shells. Each shell represents an episode where the fainter star lost some of its mass. The widest shells of gas towards the outer areas of the image were ejected earlier. Those closest to the star are the most recent. Lastly, the largest picture was taken by the JWST to date. It shows the quintet in a way researchers have never seen. The quintet is a visual grouping of 5 galaxies, of which 4 form their first compact galaxy group ever discovered. It is named after Stephen Edouard, who discovered it in 1877. The image is so large that it covers a visual field that is about 1/5 of the moon's diameter. It shows sweeping tails of gas and dust and stars that are being pulled from several of the galaxies owing to gravitational interactions. The huge shock waves caused as one of the galaxies, NGC 731AB, smashes through the cluster is seen in extraordinary detail. In this image, only 4 of the quintet are truly close together and engaged in a cosmic dance. The 5th and leftmost galaxy, called NGC 7320, is about 40 million light-years away from Earth, while the others are about 290 million light-years away. The proximity of the quintet and tightness of the group provides astronomers a ringside view of the emerging and interactions between galaxies, which is a crucial part of their evolution. The topmost galaxy in the group, NGC 7319, harbors an active galactic nucleus, a supermassive black hole 24 million times the mass of the Sun. It actively pulls in material and produces light energy equivalent to 40 billion suns. Can you see how amazing this new invention is? What do you think about this? Share your thoughts in the comment section. We absolutely can't wait to hear from you.